In this video, we're going to be talking about odd and even functions. We're going to first start off with looking at it graphically, and then we'll look at the algebraic expressions. Now, if we have an even function, these are symmetric with respect to the y-axis. I'll talk about this one here in a moment, but let's take a look graphically. I said y-axis and I wrote x-axis. These are symmetric to the y-axis, which means that the y-axis is acting as a mirror. So what happens on one side of your graph is going to happen on the other side. So reflected over here on the other side. So our graph should look kind of like this being shown on the other side and a little bit closer over here, right? But since it's not being reflected this way, this is actually not going to be reflected over the y-axis. So we know that this one is not an even function. However, taking a look at an odd function, odd functions are symmetric with respect to the origin. The origin is a point 0, 0. So your origin being right here, 0, 0, is acting as the reflector. So what should be happening up here is then alternating happening down here. So it should be directly reflected. So unfortunately, no, this one is not acting as the mirror down here. So this is neither odd nor even. It's not symmetric to the y, it's not symmetric to the origin. Now let's take a look at number 2. Now, are we symmetric to the y-axis or perhaps your origin? Well, noticing that your y-axis is cutting your graph in half, and what's reflected on this side is also showing on the other side. So therefore, this is not an odd, but an even function. What about number 3? Number 3, once more, if this is your y-axis, it's what's happening on one side of the graph should also happen on the other side. So this is, again, an even function. Let's take a look at number 4. If this was your y-axis here, what's happening on one side should also then reflect on the other side. So we can tell here this is not an even function, but let's take a look at your origin. Your origin being here, if we have been flipped up, that means to reflect over this origin, if this is acting as your mirror, this should also be flipped downwards. And we see that graph here, and it is symmetrical. So this is an odd function. How about this one? Now, again, this being your origin, what's happening above is also happening below. So this is also an odd function. And lastly, this one is neither. So this is how you can tell if your graph is odd or even. Now, when it comes to your equations, we can also determine if they are odd or even. So to evaluate whether or not your function is even, given an equation, when we plug in a negative x into your equation, if the negative does not pop out, then we are an even function. What we're trying to get at, essentially, is that if there's no sign change for your x values, then we are even. So no change to the x values. Whereas if we're an odd function, if we go to insert a negative x into your function, if the negative comes out and changes your sign, then it's odd. So again, what we're trying to get at is if all, how do I say it over here? If all terms change signs. So let's take a look at this in action. So let's take a look at this first one. If we put in a negative x into your function, so we've just replaced your x values with now a negative x. If it's even, your signs are not going to change. So the negatives do not affect your equation. Or if it's odd, that means all of your terms will create a sign change. All of the terms that we've sub in an x for, I should say. So for us, when we plug in your negative x cubed, this is really just saying negative x times negative x times negative x. What comes out is going to be a negative x cubed. So this one has undergone a sign change. Whereas when we look at your next term, negative 6 times negative x, this will create a positive 6x. So again, another sign change. So because both of these terms have changed their signs, this is an odd function. It is symmetric to the origin. So if you need something a little bit easier to see, maybe you don't like having just a symbolic value, we could, let's say, put in a negative 3, right? Well, negative 3 cubed minus 6 times negative 3. Negative 3 cubed is just multiplying by itself 3 times. And notice that negative, right? While the first two cancel, the other negative stays. So we really get negative 27. So the negative comes out, it follows. It does a sign change. And on the other one, negative 6 times negative 3 will then make it positive. So they have swapped their signs. This first x was positive. It's now negative. This next term was negative and it's now positive. So therefore, it's an odd function. Let's take a look at your next one. So plugging in a negative, anywhere you have your x value, negative x to the fourth minus 2 times negative x squared. So again, just subbing in a negative, or if you prefer, you can sub in an actual negative number, as long as your function supports the negative. So we can put in the negative, and even powers, right, will not produce a negative on the outside. Let's say this is really negative x multiplied by itself 4 times. So the negative will drop. So we get a negative, not a negative, oops. We get a positive x to the fourth minus 2. And again, this other one is just saying negative 2 times, or negative x times negative x, which makes it a positive x to come out. So that does not change the sign of your next term. So because there were no sign changes on your terms, this is an even function. So now let's look at your next term, or your next equation. So we have x squared plus 2x plus 1. So, excuse me, let's go ahead and substitute your values in. So we have h, or not h of it, well, h of negative x, or a negative value if you prefer, negative x squared plus 2 times negative x plus 1. So the negative x squared, that will remain positive. However, 2 times negative x will make negative 2x and then plus 1. So notice that these signs are now mismatched, right? This one was positive and this one was positive. This one is positive and this is negative, right? It's either an all or a none situation. So either all of your signs change or they all don't change. So this one is neither odd nor even. Not all terms changed signs. I'll do one more and then you guys can practice on the other side. So if we have f of x is equal to x squared plus 6, if you get to plug in a negative into your function, equal to positive x squared plus 6. So again, this one had no sign change, so this is an even function. All right, so try it out on the other side. Again, you can graph these on Desmos or on a graphing calculator, because now that you know what makes an odd or even function, you could then determine your answer from there. And that concludes our video.